Alright, so today we're going to talk about matter. Matter, technical definition would be anything that has volume, as in takes up space, and has mass. But ultimately, for our day-to-day purposes, what that means is stuff. All the stuff is matter. So matter can be found in one of two forms, either as a pure substance or as a mixture. And a pure substance is going to be any substance where all the particles are little tiny little pieces, and those could be atoms or molecules, if they're all exactly the same. If they're all the same. So if you're looking at a substance where if you were able to see the tiny particles, if all those particles would be the same, then we'd be talking about a pure substance. A mixture is going to be a mix of two or more pure substances. So there's particles in there that are different from each other. So if we went through a couple of quick examples, if we had an aluminum can and it was just the aluminum can, no paint on the outside, well, those are all the same atoms. They would be a pure substance. A glass bottle, well, now there's different kinds of atoms in there, but the molecules are all the same. It's all the same substance. Any single little piece of glass out of that bottle is made up of the same stuff as any other little piece of glass. So that is also a pure substance. What about concrete? So it's all concrete. But if we were to look carefully at the concrete, we would see sand and cement and gravel, little tiny little pieces that are different from each other. So those are a mixture. Candy, food, gum, actually could be really applied to any type of food. Is it all going to be the same molecules or different molecules? Well, it's bound to be different. In fact, food or anything having to do with living systems are going to be really, really complicated mixtures. Lots of different stuff in there. Water. Water would be a pure substance. Water molecules, it's a type of molecule. So all the molecules in that bottle should hopefully all be the same if it was pure water. What about coins? Well, you could have pure metals, but they would only be pure if all the particles are the same. And when we make coins nowadays, we actually put several different kinds of metals in there, so that's actually a mixture. What about wood? Well, wood comes from a living thing, so anything coming from a living thing is almost definitely going to be a mixture. Lots and lots of different kinds of molecules and atoms in there. Copper piping? Well, copper is a type of metal, and if in this copper piping there's only copper, well, then it would be pure. It would be a pure substance. Milk. Well, milk is actually part water. It's also part sugar, and part protein, and part fat. So it's made up of lots and lots of different kinds of materials, so it is a mixture. Diamonds. Diamonds are a pure form of carbon. Diamonds are pure substances. They are just carbon atoms in there. It's only one kind of atom in there. And wax. Well, wax comes from living things. So again, it's going to have lots of different atoms and lots of different molecules in there. It will be a mixture. Okay, so just a rough idea of what's the difference between a pure substance and a mixture. So, well, what's an atom? What's a molecule? So atoms are the smallest, actually, so it's really easy to say they're the smallest particles in a substance, but it's not really true, because you could break an atom up into smaller pieces. What they are, though, is the smallest particles in a substance that have all the properties of that substance. Any gold atom is going to have all the properties of gold. If you had enough gold atoms together, you would recognize it as gold. It doesn't matter which gold atom you look at, they're all pretty much exactly the same. All helium atoms are the same, and they all act the same way. You need to have a bunch of them together so we can see them and be able to interact with them to see what those properties are. But they're all the same. If you broke an atom into smaller pieces, the pieces that make up the atoms don't have gold properties, or helium properties, or iron properties. The protons in a gold atom are the same as the protons in a helium atom. They're not uniquely gold or uniquely helium. The point at which you break a piece down so small that it's no longer uniquely that substance, you've gone past the atom. So atoms are the smallest particles that still have the unique properties of the substance. Molecules are actually a pretty simple definition. A molecule is a group of atoms. They are two or more atoms that are bound together, stuck together in some kind of way where they can't let go of each other very easily. They can eventually, and that they'll always travel around together. So you wouldn't just have one, you'd have two or three, or in terms of really big molecules, maybe 300. So two or more atoms that are stuck to each other, that are bound together, that's a molecule. So if your substance is all the atoms are the same, then it's a pure substance. If your substance has atoms that are bound to each other, but all of these things, all of these molecules are the same, it's a pure substance. If you have different atoms and different molecules mixed up with each other, sure. There's two basic kinds of pure substances. Either you have a pure substance that's an element, or you have one that's a compound. Elements are substances where every atom is the same. So that was what we were talking about before. If all of your atoms are the same exact atoms, if they're all carbon, or they're all gold, or they're all neon, if every atom in there is the same, then you can predict how that substance is going to interact with other substances. You can predict what it will look like, because those atoms always have the same properties. So an element is any time you have all the atoms in your substance being the same atom. So then what does that mean a compound is? Well, if there's two types of pure substances, one where all the atoms are the same, or ones where all the molecules are the same, then a compound would be when you have different atoms, but they are bound to each other. So it's really important. They have to be bound to each other. Not just different atoms, but different atoms bound to each other in, and these are kind of a fancy term, but fixed ratio. So a fixed ratio means that you always have the same amount of each type of atom compared to the other. So we could have a molecule here, and let's not make it complicated. Let's say that there are 3 purple atoms and 1 orange atom. This molecule has 3 purples and an orange, 3 purples and an orange, 3 purples and an orange. It's always the same amount compared to each other. That's a fixed ratio. So it could be as molecules like these, where there are groups of atoms bound to each other. You can also have atoms bind to each other in structures like this, which are called crystalline networks. We'll worry about that later. But I want you to see that they're not exactly the same as molecules, but they're still the same fixed ratio. They're stuck to each other in a repeating pattern. So 2 yellows and a purple, 2 yellows and a purple, 2 yellows and a purple. And it just repeats over and over and over again. So this is a fixed ratio. Atoms stuck to each other, always the same amount of one compared to the other. If you're thinking about it in terms of like cooking and recipes, the recipe would be how many purple atoms do you need to how many yellow atoms or orange atoms. And so this is a fixed ratio. It's got a fixed recipe needed to make that substance, and this is also a fixed ratio. It has a fixed recipe of how many atoms of each type you need to put together. And they're stuck to each other. So these are compounds. This substance will always act the same. So, quick overview. Substances are made out of particles, and those particles could be atoms or it could be molecules. The substances themselves. So, in our mixtures, there are 2 different kinds of mixtures that you could have, big categories of mixtures. It's going to be 2 or more substances that, again, we're talking about ones that are, chemically bound, that are not chemically bound together. So these are 2 or more different atoms together, but they're not bound, they're not in fixed ratios. You can either have a heterogeneous mixture or a homogeneous mixture. Heterogeneous or homogeneous? Heterogeneous, homogeneous. Okay. Hetero means different. Homo means same. Heterogeneous mixtures are mixtures where the parts aren't evenly distributed. That means they look different if you were to look at a collection of soil, you would see little tiny pieces of sand, little pieces of clay, little broken pieces of plants, little tiny rocks. So it's a heterogeneous mixture of lots of different things. The pieces are usually big enough to see, and you can tell very easily that it's made up of different stuff. A homogeneous mixture has little itty-bitty tiny microscopic parts. So air is a homogeneous mixture. The pieces of it are so small that you can't see them, and they are spread out evenly. They are evenly distributed. So air has different molecules in it, different gases in it, all mixed up, but we can't easily tell them apart. If you dissolved salt in water and you completely dissolved it, this is only part. So heterogeneous mixtures are made of pieces that can be easily physically separated. You can easily separate them. You can easily see the different pieces. And homogeneous mixtures are made up of tiny little microscopic pieces that frequently cannot even be seen without a microscope. So if you have little tiny pieces so small you can't easily tell that they are separate, then we would say that's a homogeneous mixture. If you can easily see the differences between the different pieces, you probably have a heterogeneous mixture. Homogeneous mixtures are frequently called solutions. It's another word for a homogeneous mixture. So a liquid mixture that is heterogeneous could be called a suspension or something else called a colloid. A suspension is when you mix all of your stuff in a liquid, but it is heterogeneous because you can easily see that even though it's all mixed up with the liquid, it's still got separate pieces. And in fact, it'll only stay mixed up as long as you keep mixing it. If you stop mixing it, it'll eventually settle down and form different layers. A solution doesn't do that. So if you have a soda, or if you have food coloring in a liquid, or like fruit punch, those liquids, they're made up of little tiny pieces in there, like sugar and salt and other molecules, that are different than the water, but they don't separate from the water because their pieces are so small that they stay together. If they were bigger pieces, then we could easily see that they're separate from the water, and they would eventually settle into different layers. So a